Everything you were taught about the Amazon as an untouched wilderness may need to be revised. The forest that millions of people still picture as pristine, virgin, pre-human, has been quietly giving up a very different version of itself for the past 15 years. And according to a recent analysis run through Grok, the large language model with access to real-time satellite imagery, the pattern under the trees is larger, more structured, and more deliberate than almost anyone was willing to say out loud. The analysis, made public in limited form earlier this year, identified what it called statistically non-random geometric anomalies across a swath of the southwestern Amazon basin spanning roughly 400,000 square kilometers. In plain language, shapes, lots of them, circles, squares, complex polygons, connected linework, many of them only fully visible from orbit because the scale is too large to register from the ground and the canopy hides what remains. Those shapes are called geoglyphs, and the fact that they exist is no longer controversial. What's controversial is how many there are, how old they are, and what kind of society could have built them. Let's back up, because this story has been unfolding slowly for a long time. In 1977, a Brazilian researcher named Alceu Ranzi was flying over the state of Acre in the far western reaches of the country when he looked out his window and noticed something strange. Large geometric patterns were etched into the ground below, visible only because recent deforestation had cleared sections of the canopy that had hidden them for centuries. Ranzi spent decades documenting what he saw. His findings were met with polite skepticism. The Amazon, in the standard archaeological view of the time, had been inhabited only by small, scattered, mobile hunter-gatherer groups. Large-scale earthworks were a product of sedentary agricultural civilizations. The Amazon supposedly never had those. Ranzi turned out to be right, and the textbook turned out to be wrong. By the 2000s, confirmed geoglyph counts had reached the hundreds. By 2018, a study using LiDAR, which is a laser-based scanning technique that can see through forest canopy, had identified more than 80 previously unknown earthworks in a single region of Acre. By 2024, researchers estimated that somewhere between 10,000 and 20,000 geoglyphs might remain to be mapped across the basin. And then, more recently, the Grok-based analysis pushed the number higher still. The specifics of the Grok findings deserve close attention. Grok was given access to a curated dataset of satellite imagery covering the Amazon basin, along with LiDAR returns from previously surveyed zones, deforestation patterns, historical aerial photography, and a suite of terrain and hydrology layers. The model was asked to identify geometric regularities that correlated with known geoglyph profiles and to flag candidate sites that had not yet been investigated on the ground. The results, according to the team that ran the analysis, were striking. The model identified more than 15,000 high-probability candidate sites. Many were in zones currently covered by intact forest. Of those candidates, several hundred fell into what the researchers called complex networked configurations, meaning they weren't isolated shapes but appeared to be connected by linear features, possibly ancient roads or causeways, into broader regional patterns. That's what makes the Grok analysis different from earlier surveys. Previous work tended to find individual earthworks and catalog them. The new analysis suggested the geoglyphs were part of a system, a landscape-scale organization of shaped Earth that, when viewed from orbit, resembles nothing so much as the infrastructure of a functioning civilization. Before we pull on that thread too hard, several necessary cautions. First, Grok is a language model integrated with data analysis tools, not a domain specialist archaeological AI. Its findings are candidates, not confirmations. Every high-probability site flagged by the model still needs to be ground-truthed by real researchers, ideally working with indigenous communities who know the land. Some of the candidates will turn out to be natural features, geological coincidences, or modern disturbances misread by the algorithm. That's normal in any large-scale remote sensing survey. Second, the analysis has not been peer-reviewed. The preliminary report was released through a research preprint server and a short public summary. Archaeologists working in the region have been measured in their reaction, which is the correct posture. They want replication. They want field confirmation. They want to see the methodology in detail before endorsing the headline number. Third, large language models can hallucinate patterns. They are designed, in part, to find structure in noisy data, and the pressure to return an answer can bias them towards seeing geometric regularity where none truly exists. The Grok team has said they built checks against this, including comparison runs on randomized control data that should have returned very few matches. But the final judgment on whether those checks were sufficient will come from independent review. With all of that in mind, the findings are still worth taking seriously, because they line up with a trend that has been accumulating for years. The trend is this: every time archaeologists bring a new technology to the Amazon, the story of the region gets deeper, older, and more populated. When they started using LiDAR, previously invisible earthworks emerged by the hundreds. When they examined soil chemistry, they found patches of dark, fertile terra preta, which is engineered soil produced by human populations over generations. Terra preta now covers an estimated 10% of the Amazon basin, according to some studies. That's a continental-scale modification. It does not happen by accident. The emerging picture is of a pre-Columbian Amazon that supported complex societies, planned agriculture, large populations, and sophisticated land management. Some estimates now put the pre-contact population of the Amazon basin in the millions, possibly as many as 10 million people. The collapse of those societies, driven primarily by disease introduced after European contact, happened so quickly and so completely that by the time explorers arrived to describe the region in detail, most of what had been there was gone. The forest grew back over the ruins. In this context, what Grok found isn't really a new story. It's a quantitative extension of a story archaeologists have been telling for 20 years. The question isn't whether the Amazon had big, organized societies. It's how big, how organized, and how much is still waiting to be mapped. Now to the part of the Grok analysis that has pulled people in and made it a conversation beyond academic circles. Some of the geometric patterns identified by the model have a feature that earlier surveys had noted occasionally but had never systematically cataloged. They align, in specific configurations, with astronomical azimuths. That is, the shapes point, at where certain stars or solstice events occur on the horizon. Several individual geoglyphs had been noted to have solstice alignments before. What the Grok analysis appears to show, if the candidate sites hold up, is that these alignments may be a recurring feature across thousands of sites, distributed over a region the size of several European countries. If that finding survives review, it would suggest a coordinated tradition of astronomical construction spread across vast distances, not isolated communities building similar shapes by coincidence. A shared system, maintained over centuries, maybe longer. The model also flagged something else, which was more speculative, and which the research team was careful to describe as tentative. Certain clusters of geoglyphs, when plotted across the landscape, appear to form larger meta-patterns. Groupings that, at continental scale, look organized in ways individual local patterns don't account for. This is where independent review matters most. It is exactly the kind of finding where confirmation bias can take over, but it's also exactly the kind of finding you'd expect if the underlying civilization had been more centralized and coordinated than standard models assume. Here is where the skeptical view needs to come in, and it comes in strongly. Dr. Elena Moreira, a paleoecologist at the Federal University of Pará, who has worked on Amazon earthworks for over 15 years, has pushed back firmly against the framing of the Grok findings. She argues that the model is overfitting. Satellite imagery contains many kinds of regular features, including modern land parcels, abandoned plantations, logging roads, and drainage patterns, any of which can produce false positives that a model with a bias toward geometric matching will pick up. She has also cautioned against what she calls continent-sized narrative escalation, the tendency of remote sensing work to claim ever more ambitious conclusions as the scale of the data grows. Moreira's critique is important. It represents the scientific process doing exactly what it should. Until the Grok findings are checked, parsed, and field verified, the most responsible position is to treat the number 15,000 as provisional. But even Moreira accepts that the number of verified geoglyphs is growing rapidly, and that earlier estimates of the pre-Columbian Amazon population were almost certainly too low. What she contests is the scale of the new numbers, not their direction. Taking the most conservative view, the following seems robustly supported. The Amazon was not a pristine wilderness. It was shaped by human hands over many centuries. Large portions of what looks wild today were engineered landscapes. The people who built the geoglyphs were not isolated hunter-gatherers but members of societies with planning, labor mobilization, and probably astronomical knowledge. Some of what they built is still there, under the trees, waiting to be seen. Taking the more ambitious view, if the Grok analysis holds up, the Amazon basin may contain the largest network of pre-Columbian earthworks on Earth, rivaling or exceeding any region previously considered the center of ancient landscape modification. That would reshape how we think about where human civilization developed, where it scaled, and what it looked like outside the narrow band of river valleys and coasts that have dominated traditional history. The implications run further. If the geoglyph network is truly continent scale, it forces a reconsideration of questions that have been lingering for decades. How much of what we now call the Amazon rainforest is, in a sense, a human artifact? How much of the tree species composition was shaped by the agriculture of people who lived there before? How much knowledge was lost when those societies collapsed? How do we factor indigenous stewardship into conservation and climate policy when the land itself shows the fingerprints of millennia of intentional management? These are not just academic questions. They matter for current debates about land rights, climate strategy, and how to treat the indigenous communities who are direct descendants of the people who built the geoglyphs. If those communities are seen not only as inhabitants of the forest, but as inheritors of a sophisticated, long-standing civilization with sustained experience managing the land, their voice in policy gets harder to ignore. That shift is already underway. Brazilian and Peruvian researchers have increasingly partnered with indigenous communities on geoglyph surveys. The partnerships have produced findings that wouldn't have been possible from satellites alone, because local oral traditions sometimes encode knowledge of sites that haven't yet been mapped. The future of this research is going to look less like lone archaeologists with trowels and more like collaborative teams combining remote sensing, machine learning, community knowledge, and targeted fieldwork. Grok's role in that future is worth thinking about carefully. Large language models are powerful pattern finders. They're also potentially unreliable, vulnerable to bias, and capable of producing confident-sounding nonsense. The right use is as a first-pass tool. Let the model scan vast datasets and flag candidates. Send humans to check. Correct the model. Run again. Over time, this loop can accelerate what has historically been slow, piecemeal work. But the loop only functions if the human checking remains rigorous. For now, the honest summary is this. The Amazon holds more archaeology than we knew. Every new survey pushes the count higher. The latest analysis, run through a large language model, has suggested a scale that would be extraordinary if verified. Verification is ongoing. Some of the findings will hold. Some will wash out. The truth will land somewhere between the conservative and the ambitious positions. And even the conservative position already overturns the old story of a people-free forest. Somewhere in the next several years, researchers will know how much of the 15,000 figure was real. Whatever the final count, the direction of the revision is already clear. The forest has been hiding a civilization, or the remains of one, for a very long time. Cameras in orbit, lasers on helicopters, and now language models parsing the pixels are slowly lifting the canopy in our minds. What we're seeing underneath is not empty ground. It's the footprint of people who lived and worked and watched the sky, and who shaped the land so thoroughly that 4 centuries of regrown rainforest still can't quite cover the evidence. The shapes remain. The questions remain. The work is just getting started. Whatever the final count turns out to be, the old narrative of the Amazon as a people-free paradise is over. What replaces it will depend on how carefully the next generation of researchers, algorithms, and indigenous partners handle the evidence already in the ground. It's worth walking through some specific examples of what's already been documented on the ground, because the ambient abstraction of numbers can obscure how tangible this evidence is. In Acre, near the border with Bolivia, a complex known as Fazenda Atlantica contains a precisely square ditch enclosure about 200 meters on each side, with perpendicular avenues extending from each side and a smaller concentric circle at the center. The ditch is over 3 meters deep in places and required moving tens of thousands of cubic meters of earth. Radiocarbon dates from organic material in the ditch floor place construction roughly 2,000 years ago. A few kilometers away, an octagonal enclosure with a smaller inner octagon rotates its axis by 22.5 degrees relative to the outer wall, an arrangement that has no obvious practical function and strongly suggests deliberate geometric design. Neither of these sites is speculative. Both have been mapped, excavated, and published in peer-reviewed literature. What Grok's analysis claims to add is scale, not the existence of individual sites, which is already established, but the estimate that thousands more remain hidden under canopy and that they may be connected in ways we hadn't appreciated. If that estimate is even half right, researchers will be busy for generations. There's a parallel from a different part of the world that illustrates how this kind of estimate can turn out. When LiDAR surveys started covering the lowland Maya region of Guatemala and Mexico in the 2010s, the results genuinely astonished the field. Entire cities that had been invisible under jungle were suddenly drawn in outline. The population density implied by the new maps was several times higher than earlier estimates. Field archaeologists had to rewrite their sense of what the ancient Maya region supported. Some of the new findings were contested, refined, walked back. But the overall picture of a denser, more connected, more extensively cultivated pre-contact landscape held up. Remote sensing revealed a civilization that had been there the whole time, just below the tree line, invisible to the naked eye. The Amazon may be walking the same path. What was once imagined as unmodified forest turns out to be covered in earthworks, shaped soils, managed tree species, and now, if the latest analyses survive scrutiny, a network of geoglyphs that encodes astronomical and possibly symbolic knowledge across a continental expanse. Each new survey technique peels back another layer, and each layer reveals more human intentionality than the previous model assumed. Another element of the Grok findings worth mentioning involves the hydrological context of the geoglyphs. Many of the shapes are located near, but not directly adjacent to, major river systems. Instead, they cluster along what were once secondary waterways, many of which have dried, shifted course, or been absorbed into seasonal wetlands. The analysis flagged this pattern and suggested it might reflect the availability of both freshwater and elevated, drainable land, which is typical of agricultural settlement. If that's right, the geoglyphs aren't just ritual or astronomical monuments. They were built by people who needed a specific kind of landscape to feed themselves and who found that landscape in the transitional zones between rainforest and savanna. That's a piece of ecological reasoning that supports rather than contradicts the archaeological findings. The implications for conservation policy are significant. If portions of the Amazon, are shaped landscapes maintained through millennia of indigenous management. Then protecting those portions in a state of pure wilderness may actually be ahistorical. It may even damage what's there. Some ecologists now argue that certain Amazon regions need active indigenous stewardship, not passive protection, to preserve the ecological communities that evolved under human care. That argument runs against simpler conservation narratives, and it's politically complicated, but it's increasingly supported by the evidence on the ground. None of this settles the question of who built the geoglyphs, or what language they spoke, or how they organized themselves. The cultural and linguistic affiliations of the people who shaped Western Amazonia 2,000 years ago remain mostly unknown. Descendants of those populations, to the extent they survived the epidemics and displacements that followed European contact, live in scattered indigenous communities across the region. Connecting the archaeological record to living traditions is a painstaking, collaborative process that's only recently begun in earnest. Some oral histories record knowledge of ancestor paths and geometric marks in the ground that seem to correspond to known earthworks. Those traditions, long dismissed as folklore, are being listened to more carefully now. The story the ground is telling, with help from satellites and algorithms, is not of a primitive past. It is of a continental civilization that arranged land, tracked stars, organized labor, and left a record we are only beginning to read. The record is damaged. Much of it is gone. But enough remains to require a new mental image of what that part of the world looked like before the arrivals that reshaped it. In the weeks and months ahead, expect more announcements. Expect some of them to be overstated. Expect others to be quietly corrected. The pattern of remote sensing research is that the first headlines rarely age well, but the underlying direction of discovery tends to hold. The Amazon is fuller of human history than we thought. Every year, it turns out to be fuller still.